Hello everyone, good afternoon, good day, it's Japi here, and for today, we're gonna be doing part 2 of our previous topics for physics. And as you can see guys here, I probably have already seen this on thumbnails, but we're gonna have 3 topics. Or we're gonna have like, how many problems is this? 1, 2, 3, 4, 5, 6, 7, 8. 8 problems on hand, okay? So probably we're gonna separate this into 3 videos or 2 videos, but we're gonna be solving this today, and I'm gonna be uploading this probably together or separately, but by batch. Anyways, we're gonna be solving 3 topics: statics, kinematics, and work, power, energy. I hope you guys are excited for more problems, and you guys are willing to learn. And yeah, I'm trying to accommodate questions. If you guys notice that sometimes my teaching strategies or the way how I solve things is different every now and then, is because sometimes I try to accommodate what my students like. If ever a student of mine asks something, I try to accommodate that question, and which one is like, which one they are like having a problem with. Okay, so maybe if you guys don't have if you guys are having a hard time with the questions, with the problem solving, or with how we solve things, you guys could ask a comment, or could comment below, or you could just probably slow down the video or check out other videos of mine on how we solve these types of problem. Okay, this is not the first video for statics, not kinematics, for work, power, energy, but hope you guys are excited. Let's solve for the first one. Okay, so first one is statics, and we seem have like a distance here. Okay, we have distance of each parts of the system. 50. Well, what 51? A fixed crane has a mass of 1,000 kilogram. A fixed crane has a mass of 1,000 kilogram and is used to lift a 2,400 kilogram crate. Okay, so the crane is the 1,000 kilogram and 2,400 kilogram crate. Okay, and it seems on the diagram the G is the center of gravity. Okay, so meaning the 1,000 kilogram is already here. Okay, 2,004 kilogram grain on a crate. It is held in place by a pin A and B. Pin A at a rocker B. So A is a pin. Though probably there's an AX there and AY. And we have motion, or we will have rotational motion at the pin. Okay, pin allows rotational motion. Pin is like the seesaw. It allows rotational motion, but it doesn't allow movement or transitional motion. Determine the component of the reaction at A and B. So A is a rocker. I'm guessing it will have a normal force B there. Okay. Okay. How about we... Okay. Alright. So first off, I'm not gonna put... Oh wait, we can. We can. NFB. We don't know the angle. Okay. So how about let's try... Okay, I'm just thinking how to solve this. But how about let's just try to solve it normally. Okay? Let's try FBD first. FBD at crane. Okay, if we try FBD at crane, the whole crane, we're gonna be having 2,400 downward, 1,000 kilogram downward. Okay, so if you guys are asking, Japi, why are you not transforming it to Newton? We could do the Newton later. Okay, we could find the force later. Okay, we could just stay as 2,400 and 1,000 kilogram as is. If we know that every unit in the solution will not be a force but a weight, you know. AX, AY, upward, and that's it. Okay, and I'm gonna erase AX. I'm gonna put AX to the left. Na AX to the left, and then NFB to the right. Okay. So there must be okay, at the end of the day, there must be equal leftward force to the rightward force, upward force to the downward force. Okay. Okay. So AY is 3,600 kilogram, or times 9.81. AY is 3,600 times 9.81, 35,316. 35,316 AY. Right. Newton. This one is kilogram, right? So that's AY. Okay, that's just for now. How about AX and BY? NFB. No, not BY, AX and NFB. We can't do anything for now. Okay? I'm not sure if this is the correct answer, but let's proceed to moment and torque. I'm gonna do moment at A clockwise, you know. Moment at A clockwise. I'm gonna make a copy of this. Oh no, we already have an original copy. This one is the original copy. I'm just gonna make do with this. I'm gonna do formula for moment of torque. Moment or torque is M is equal to force times distance perpendicular. Okay, this is A. Okay, we're doing counterclockwise. So G is negative 1,000 times 9.81 times 2 meters. That's the moment for letter G. Okay. Then for the crate is negative 2,400 times 9.81 times 6, because the distance is 6 meters away. AX the distance of AX is 0, the distance of AY is 0. Okay, we have one last force, NFB. NFB is counterclockwise. This is NFB, and we have 1.5, right? So positive NFB 1 times 1.5 meters. Okay, 1.5 meters. What else? I think that's it. It's already positive. Okay, it's already we don't need to transform it to newtons. Okay, the whole equation will be at newtons. We're gonna be equating it to 0. Okay, this is a crane, this is a system, and I assume that this will be, we're gonna assume if the crate is to like have, or to lift the crate, right? Assume equilibrium. Okay, we're gonna assume it's in equilibrium. Okay, NFB will be equal to NFB will be equal to 1,000 times 9.81 times 2 plus 2,400 times 9.81 times 6 divided by 1.5 meter. NFB will be, okay, so top is 2,000 times 9.81 plus 2,400 times 6 times 9.81 divided by 1.5. NFB is 107,256 Newton. What's that in mass? Or 10,933.3333 kilogram. Okay, that's NFB. Alright. If we take a moment at different instances, if we do NFB, we're just gonna, if we take a moment at B, we're just gonna get the same thing. I think we're just gonna get the same thing. So it is safe to say that you guys could try at home. But if you take a moment at B, we will get just, oh, AX will be equal to B. You know, just a different direction. AX is just going to the left. And AY is just going to the right. AX is going to the left, and F is going to the right, and AY is going upward. Okay, and I could say that this is the answer. You know, there's no more source, or there's no more equations that I could use for statics, and I think this is the correct answer. Right, 35,316, and AX and NFB is 107,256. AX is going to the left, and NFB is going to the right. It makes sense because the crane, right? If you're a crane and you have like a weight going downward, right? What the B part here will be probably rotating to the, you know, clockwise, right? Rotating clockwise, and the reactions of B will be going to the right, while the reaction of A is going to the left, because the machine is rotating clockwise. The pin will be pulled by the system, so the pin is reacting to the left, or it's opposing the rotating motion. Okay, anyways, I think that's it. Let's if you guys have any question, it's a little bit fast. Let's continue to number 2. Let's continue to number 2. Oh, this will be faster. This will be faster. Okay? Okay, shown in the diagram below, determine the value of P shown in your solution. Okay? So, first, if the pulleys doesn't have any weight, assume pulleys, because there's no other given, you know. Assume pulleys doesn't have weight. Okay. The wires doesn't have weight, right? My writing is very bad. Okay. Okay, okay. Assume pulleys have no weight. Right? 800 Newton. Okay. Now, so in the diagram, we could just name it tension 1 and tension 2, you know. And it seems in the diagram that tension 1, tension 2 is equally in distance. So I could say that tension 1 and tension 2 will be 800 Newton. Okay? When you add tension 1, tension 2. And they have the same distance in the diagram below. You know, if there's a given distance, we could solve for it. But for now, I would assume that they have the same distance. And if they have the same distance, we could say that, how about let's just do moment, you know. Moment at, let's say, at this corner. No, moment at the center. Moment of the center, if they have the same distance, you know, moment at center clockwise will become, tension 1 will be pulling upward, so it's gonna be positive T1x minus T2x is equal to 0, and T1 will be equal to T2. Okay, FBD at the pulley, no, not the pulley, at the bar, The bar is the 800 Newton one. Okay. Japi, why aren't there any, in your moment at the center, why are there no 800 Newton? The 800 Newton weight is at the center of gravity, meaning if we take a moment at the center, there won't be, the distance of the 800 Newton is 0. Okay, the moment at the bar, the FBD at the bar, 800 Newton downward, T1 upward, T2 upward. T1 plus T2 is equal to 800 Newton. T1 and T2 is the same. T2 to T2 is equal to 800 Newton. T2 is equal to 400 Newton is equal to T1. Right? So T1 and T2 is 400 Newton. Right? I'm gonna rename this as 1, 2 pulleys, 3 pulleys, 4 pulleys, and 5 pulleys. Right? So I'm gonna do an FBD at pulley 1, P1. There will be tension 3, tension 4. Now tension 3, tension 4 over tension 2, which is 400 Newton. Right? And you know what we say about pulleys, the tension in the pulleys or the connected tension in the pulleys should be equal. Meaning T4 is 200 Newton and also T3. Okay? 200 Newton. Okay? Are you guys getting the what's happening here? So T3 is a tension going to, look at this, right? So T3 is a tension going to the leftward, okay? Or going to the second pulley, okay? And if T3 is a connecting cord on a pulley, so meaning T3 and T5 will be the same. And T5 and T6 will be the same. Okay? T6 will be the same, right? Right? Are you guys getting it? Are you guys getting the connection here? Right? Okay. T3, T5, and T6 will be the same. Alright, now there's an FBD now at the pulley 4. FBD at P4. Now, this is the P4, right? This one is 400 Newton. This one is 200 Newton. And in order to balance the FPD, you know, if this is 400 downward, 200 downward, then we get to say T5 or T6, T6, T7, we can just call this T7. T7 will be 200 Newton, this one, because it needs to be the same Newton force. Okay, next, and if this is the same, this should be the same. T7 is equal to P, and P is equal to 200 Newton. Okay, that's it. That's it. That's the answer for our pulleys. Okay, how many minutes is that? Oh, it's pretty fast. Well, not so fast. It's been a long solve. Okay, anyways, now that we solved 2 problems already, we're gonna be continuing to question number 3. Question number 3 for statics. Let's go. This one is, I would say, probably a lot harder than the other ones. Let's see. This looks complicated. Brought to you by matalino.com. I hope we can solve this very easy. First off, for letter A, what should we do? Right? How about we draw the diagram first? This is P. You know, and if this is a full circle, this will be 10 inch. This is 1,000 pounds, and this will be 10 inch too, you know. And if this is a 5 inch, meaning the distance at this point, let's do that. moment at that point. Is the reaction also needed? No, there's just the P for letter A. Also find the no, they want also to find the reaction of the. Okay. Anyways, I'm just gonna make a moment at the point of reaction, counterclockwise, meaning that the P distance perpendicularly will become positive P, and distance is 5 inch. Because if this is, if this is 5 inch, and this will be 5 inch, because that's 10 inch. But for the 1,000 pound, the dogs are barking. I'm sorry, guys. If this is 5 inch, this is 5 inch, this is 5 inch, right? This will be 1,000 pounds. And this is P. Alright, this is P, right? Alright, oh, and also this hypotenuse is 10 inch, right? Because, yeah, that's the radius, that's the 10 inch, right? Okay, this is the radius of the circle. Alright, and this is 5 inch, meaning this is 30 degrees. So, minus 1,000 pound. The distance is 10 cosine 30 degrees, right? Cosine 30 is half. Let's try it again. Or if we want a formula, sine theta is equal to 5 over 10. Opposite over hypotenuse, theta is equal to 30 degrees, right? Meaning P is equal to 0. 1,000 times 10 times cosine 30 divided by 5. What would be the answer? Times 10 times cosine 30 divided by 5. 1732.0508. 1732.0508. Okay. Pounds. Alright, that will be the answer for P. Oh, one. Alright, and we can do an FBD at the reaction. FBD at reaction. Alright, at the reaction, if the reaction is to be normal force, so the reaction will be here. P is to the left, P, and 1,000 pounds is downwards. Okay. And we could say that I'm gonna assume this is 30 degrees. I'm gonna assume that's 30 degrees. But for now, I'm just gonna put it as theta. We can solve for theta too, And P is 1,732.0508. Okay, so Rx is equal to P, or 1732.0508, or equal to R cosine theta. Ry will be 1,000 pounds is equal to R sine theta. Okay, and R tangent, so meaning tangent theta, or R sine theta divided by R cosine theta, cancel R, it will be 1,000 divided by 1732.0508. Theta is, I'm guessing this should be the same as 30 degrees. Okay? See what I told you guys, I'm a prophet. I'm a god. Just kidding. Alright, so 30 degrees. Alright, the angle is 30 degrees. Because it's a tangent. It's a circle, and it's touching tangentially. So the surface must be a tangent or perpendicular, or So the reaction will be normal force or perpendicular to the center or going to the center. It means it's gonna be 30 degrees. Okay, long story short. Okay. What now? So we got 30 degrees. So R is equal to 1000 divided by sine 30. What is R? 1000 divided by sine 30. 2,000 pounds. Okay? 2,000 pounds. R is 2,000 pounds. And that will be the answer to A. Okay? 2,000 pounds R, 1,732.0.008 pounds per letter P. Okay? If the force P may be inclined at any angle, oh, that's gonna be hard. Okay? If the force P may be inclined at any angle, determine the minimum value of P. P minimum starts with the wheel over the block. The angle P makes by the horizontal direction of the block. Okay, it seems to me that we have three forces working. Okay, the 1000, the reaction, and the P. Now, how about let's make P here, P theta, and this is R, 30 degrees, R, and 1000. There's three unknown in the system. We cannot, we're not gonna be able to solve for this. Okay, we're not gonna be able to. There's three unknowns in the system. So what do we do now? How about let's make a triangle. 1000 going downward. 1000 pounds going downward. We know the angle of R, 30 degrees. Meaning this will be 60 degrees. R and P, right? This is theta, right? This is P, right? Alright. So first is we know at least one angle. Let's do sine law. I'm trying to differentiate, okay? Because we have three unknowns and it says minimum, right? And when we different ones, we can get the minima and maxima, right? We can, if we differentiate, right? So if this is 1000, how about P over sine 60, right? Is equal to 1000 over cosine theta. No, cosine. Sine theta plus 30 degrees. Isn't that right? So P sine theta. No. P is equal to 1000 sine 60 over sine theta plus 30. Right? Okay. So how about we differentiate P with respect to theta? Okay. Meaning the sine theta downward, right? Downward, VD squared will become negative 1000. Oh, how about I just let U? Let U is equal to sine theta plus 30 degrees. And du will be cosine theta plus 30 degrees. Okay? D theta. Okay? The differential of 30 will be 0. Because it's a constant. So it's gonna be the same. Okay? It's gonna be the same, right? So, oh, wait. Oh, meaning, if we differentiate 1 over u, if we differentiate 1 over u, that's u negative 1, we will have negative, right? 1 over sine theta plus 30 squared cosine theta plus 30 d theta. Alright? So, meaning we're gonna have 1,000 sine 60 degrees cosine theta plus 30 d, the d theta is already downward, you know, over sine squared theta plus 30. Okay? Okay, that's it, you know. And if we're gonna get the minimum, dp over d theta should be 0. Okay? Meaning 0 is equal to negative 1,000 sine 60 cosine theta plus 30 over sine square theta plus 30. Alright? Okay. Multiply both sides to sine square times 30. Right? Divide both sides by 1,000 sine 60. Will there be any values here? No. Right? Will there be any values? Okay, so the dog is barking. Let me just... Okay. The dog barks have subsided. Let's continue. So, multiply both sides by the denominator, 0. Divide both sides by negative 1,000 sine 60. Cosine theta plus 30. Just believe in yourself. Divide both sides by the coefficient. And anything... Oh, come on, mouse. You can do it, mouse. Okay. Anything, 0 divided by anything is 0. So, 0 is equal to cosine theta plus 30. And cosine of 0 is 90 degrees is equal to theta plus 30. Theta is 60 degrees. Right? So, the most efficient or minimum angle is 60 degrees. The most efficient or the angle P with mix with the horizontal, the reaction of the block, determine the minimum P to start the wheel over the angle P mixed with the, okay. So, the angle P mixed with the horizontal is 60 degrees. Okay, that's the angle. Let's get P. You know, this one, right? P is equal to 1,000 sine 60 over sine 60 plus 30. So, what's that? 866. Sine 90 is 1. You know, if you want to be fast with your problem solving, just, you know, do it fast. 866.0254 pounds. Okay, that's the value of P. Okay, and if that's the value of P, we could go back to this one. You know, P. This one. Okay. P over sine 60. Okay, is equal to R. Okay, over sine 30. Okay. Sine 30, you know. Okay, so why is 30? Because theta is 60 degrees. This one is 30 degrees. So it's gonna be a 90 degree angle. You know, with 1,000 pound. With 1,000 pound at the opposite of the 90 degree angle, then P is at the opposite of 60 degrees and R is the opposite of 30 degrees. And with that said, I think R will be R is equal to 866.0254 sine 30 divided by sine 60. I think R will be 500 divided by sine 60 times sine 30. Okay, R is 500 pounds. And that's the best way to do it. That's the minimum force. Okay, I hope you guys, learned something new. Okay, so that's differentiating in the physics problem. That's pretty new. Just go with the flow. Just always remember the key terms, the concepts that you learn from different subject. And yeah, when it comes to minimum, you differentiate. Okay, when in a parabola or in a diagram, when the slope rise over run reaches to its maximum, the reaches to 0, that will be the maximum point. The same as going downward. If the slope is negative and it reaches 0, that will be the minimum point. Okay? Well, it doesn't necessarily mean the minimum point forever or the minimum point overall. Okay? It will be the minimum point or the stopping point to which your slope will change. Okay? Because sometimes diagram can be this one. Okay? It will have 2 minimum points. Some diagrams will have 2 maximum points. Okay? In this case, we just only need 1. Okay? Anyways, hope you guys have learned something. If you guys have any question, feel free to comment below. And if you guys learn, like and subscribe. Thank you so much. Let's proceed to kinematics.